Okay, so we're back with another video, and in this video we're going to be going over some more Euclidean questions that has to do with your prop theorem, just so that you get more accustomed to it, just so that you can get used to it. And just a little reminder, guys, if you struggle with any other topics in math, trigonometry, remember on this channel we just cover Euclidean. I am hosting online sessions every single day for both math and physics, so please make sure, guys, if you want to join, just comment down below so I can share more details with you. But as for now, let's get started. 11.2 in the diagram, OP is parallel to LM such that the area of triangle KOP equals to the area of quadrilateral OLMP. KYX is perpendicular to OP and LM at Y and X respectively. Okay, so before we begin, there are a few there are a few rules we have to remember when it comes to parallel lines. So we usually think of co-interior angles, we think of alternating angles, right? And we also think of corresponding angles. And corresponding angles is something that it's kind of a rule that a lot of students are kind of confused about, even though it's something we've learned all the way back in grade 8 and 9. But yeah, so corresponding angles is basically when you have two parallel lines and then one angle before one parallel line is equal to the other angle that comes off the other parallel line, right? So that is exactly how corresponding angles work. So we have OP that is parallel to LM. So what does that mean, guys? So we can clearly see that means O1, remember the angle that comes before one parallel line is equal to the angle that comes after the other parallel line. So we have O1, which equals to L, okay, because of corresponding angles. So you just want to go back and mark that off before you start. And then we have P1 that equals to M, right? Now, this is one thing that a lot of students also kind of forget. When they tell you that a line, you need to go back and read the information above. They told us that KYX is perpendicular to OP. When we think of a line being perpendicular to another line, what do we think of? We think of that line bisecting it. We think of that line meeting the other line that it is perpendicular to at a 90-degree angle. So what exactly does that mean? Well, that means that Y2, since they said KYX is perpendicular to OP, right? That means Y2 is going to be 90 degrees and Y1 is going to be 90 degrees. Okay, one thing that I also want you to remember is corresponding angles. Remember, guys, corresponding angles doesn't only apply to the angles that are literally on the edge of the line. It can also apply to the angles that are literally like sitting in the middle of that parallel line. So what does that mean? We can see Y2 is in the middle of OP. Y2 comes before line OP. So Y2 is going to equal to the other angle that comes after the other parallel line, which is X2. So we have O2, which is also equal to X2. Same thing with Y1. Y1 is an angle. It is before one parallel line, and it's going to equal to the other angle that comes after the other parallel line, and that means it's going to be equal to X1, right? So now, what else are we missing? What else do we have to go back and look at? Okay, so by the way, guys, if you are currently going through these questions where we're clearly going to be proving ratios, I want you to write down a few rules for yourself on a piece of paper. I want you to think of maybe having to prove similarity in certain triangles, maybe congruency, obviously your prop theorem, your midpoint theorem. So before we begin, let's go back and see if the prop theorem would actually apply, right? So remember what our prop theorem tells us, guys. If we have a parallel line, we have parallel lines that are obviously parallel to each other and they are literally in between a triangle. That means that those parallel lines divide that triangle in proportion, right? So we can see that we have OP that's parallel to LM. So what does that mean? That means KO over OL is going to be in proportion to KP and PM. But before you begin, guys, this is a lot of students actually forget about this. Even if we have like a line that's kind of bisecting that triangle into two equal parts, this one side of the triangle is still going to equal to the parts of the bisector, right? Of the bisector line that's kind of dividing that line in half. So what does that mean? That means KO is still going to be in proportion to KY, and OL is going to be in proportion to YX. Right, so let's get on to question 11.2.1. We have to prove that triangle KOP is similar to triangle KLM. Okay, so KOP, so we're looking at KOP and KLM. So basically the smaller triangle KOP and then the larger triangle KLM. Now, how exactly do we prove that two triangles are similar to each other? You want to look at their letters. You want to look at the letter arrangement, the way that they've been arranged in the name of the triangles. So, by the way, this is not like an actual valid, this is not something, to completely confirm. It's not like if the triangle starts with a K, it doesn't necessarily mean that K in triangle KOP is going to equal to K in KLM. I just want you to, use that as your starting point. So let's look at K and KOP. K in KOP would be K1 and K2. So we want to check to see if K1 plus K2 is equal to K in KLM. Okay, so K in KLM is also the K in KOP. So obviously that's like that's a common angle, right? So there we already have like one reason. We've already given one statement. K equals to K because they're both common they're common in both triangles. We had K in triangle KLM, which is literally right here at the top. Then we had K in the larger triangle, which was KOP, which also shares the K right here at the top. So for that reason, they're going to equal to each other because they're common. Now let's look at O in KOP. So what angle is O in KOP? That would be O1. And what is L in KLM? KLM. So L in KLM would be this L angle over here. And then O in KOP would be O1. And we've marked them as being equal to each other because of corresponding angles. So you're going to go back and you need to state which two lines are parallel to each other. That kind of allowed us to write this as our answer, that validated our answer, okay? So you want to go back and write down O1 equals to L because of corresponding angles, equals to, comma, OP parallel to LM. The last thing is, now, when it comes to the third angle, guys, those third angles are automatically going to equal to each other because of sum of angles of the triangles. Just a rule. When you're using similarity, when you're trying to prove that two triangles are similar to each other, the third angles are automatically going to equal to each other, okay? So you want to go back and write down P1 equals to M. Over here they state the fact that it's because of corresponding angles. If the third angles are equal to each other because of that, by the way, guys, because there is an actual rule connecting them to one another that allows them to be equal to each other, then yes, you can write it down. But if you can't really find a rule at all, then we already know that the third angles are automatically equal to each other. But I already stated this, that P1 is equal to M because of corresponding angles, and then you have to state the two lines that are parallel to each other that allows us to validate our answer. And please don't forget the last part. You're going to therefore confirm the fact that they're both similar to each other because of angle, angle, angle. We've proved our answer. The proof that we gave all had to do with angles being equal to each other. So you just want to go back and write down angle, angle, and angle. Then for question 11.2, we have to prove that ky over kx equals to op over rm. Now, please remember, guys, a lot of students forget. This is why, Euclidean can be so easy if you just follow a few steps. The minute you prove that two triangles are similar to each other, you need to go back and write down their ratios, okay? So what I'm going to do is I'm just going to go back and write down their ratios. How do you write down the ratios? Just follow the sequence of the way, the triangles have been named. So KO, I just want to quickly go back and write down your ratios. So I basically grouped the two lines together. KO over KL equals to OP over LM, and then you're going to take the last two letters of each triangle, K, the first and the last letter, KP over KM. And then, remember, guys, you want to look at which fraction over here, which ratio over here has lines that are a part of, not all of the lines have to be a part of this ratio, guys, but you just want to look and identify a common line. Okay, so we have KY. Is KY a part of these ratios? No, it is not. What about KX? Do we see KX? No, we do not see KX. What about OP? Yes, we do see OP and we see LM. Okay, so that's perfect. We definitely know that we're going to be using this ratio over here. Okay, but which other, because remember guys, you have to group it. You can't just pick OP over LM. No, you have to pick OP over LM with either KO over KL or with KP over KM. And in this case, it really depends, guys. Remember, we're trying to connect OP over LM to KY. So let's just look at where KY is. KY over so let me just say KY over Kx. Okay, so before we move even further, remember that Ky over Kx is going to be in proportion to this side of the triangle, to the left-hand side of our triangle, because of our prop theorem, right? So we already know that Ky over Kx is going to equal to Ko over OL, or it can equal to KO over KL, which is a ratio that is a part of the ratios that we've already written down, right? So that's definitely going to work. So you first want to go back and see if we can identify the OP over LM that was a part of the ratio that we've already written, and then you want to see how we can connect OP over LM to KY over KX. Okay, so you first want to go back and identify where KY over KX is, and then try and see if the prop theorem is going to work to your advantage. Okay, so just like that, very easy, very simple, guys. You want to go back and first write the fact that KO over KL equals to OP over LM. KO over KL equals to OP over LM. Why is that? Because we've already proved that through similarity in the previous question. And now, remember, just like I said previously, ky over yx is going to equal to ko over ol because of the prop theorem. Or you could just go back and write down line parallel to one side of triangle. That's a rule you can also use. Therefore, ky over kx is going to equal to op over lm. Why is that? Because they're both have a ratio in common. They're both equal to ko over kl. Okay, guys. So please make sure that if you would like to improve your geometry, if you would love to improve Euclidean geometry, then you need to go over this video over and over again. If you would like the actual PDF with the questions, then you can just send me comment down below. And yet again, guys, if you really want to really intensively prepare for your finals, if you've been struggling, if you've gotten low marks before, what you want to do is you want to comment down below. You want to join as soon as possible, because there's not a lot of time left until you write your final exams. But as for now, I'll see you in the next video.